The horizontal range is going to be a bit trickier. So if you go to the game, you're going to remember that we're using this aspect ratio here, 9 by 16. So this is a widescreen device. Notice that I'm in the game window, by the way. If you select the player game object and set its position to 4, it's going to be in the right limit. If you set it to -4, it's going to be in the left limit. Okay, it works just fine. And if you select the main camera, remember that we set it to be orthographic. So the orthographic size of it is going to be 8. So as you see, the size is 8, but it varies between +4 and -4. However, if the player is playing the game in an iPad, for example, and we change this to 3 by 4, if you select the player, you change the position to 4, you notice that there's still a little limit, a little offset that you should be able to move to because you're not in the limit of the screen. And we could use -4 and we still have that offset. Okay, but if you look at the main camera, the size is still 8. Okay, this hasn't modified, so we need to make a little trick in our game, a little mathematical operation to change how this works. Okay, so we're going to mono here, and we need to have a reference for our game camera. So let's replace this UI by something like visuals, and we're going to add here a public camera, game camera. Okay, let's save this. We're going to Unity, and let's assign that camera to our game controller. So we select the game controller, we get the main camera, and we drop it here in the visual sections, just above the info text. Okay, and there should be a way for us to know what is the value for the camera. Okay, so if we come here and we want to know the aspect of the camera, we can type debug.log camera.aspect. Okay, actually game camera.aspect. So let's save this and we're going to test this out. We go to Unity, we wait for the compilation to be complete, and now we press play. Okay, so you can see the aspect right now is 0.75 because we are in a 3 by 4 aspect ratio. If we change to 9 by 16, it's going to be something different, which is going to be 0.56. Okay, so this is something that we should use. If we select the player and we set in the position 4 in the 9 by 16 aspect ratio, we are in the right limit. So this is something that we should use. And we should use in a way by knowing that the original aspect for us, okay, the base aspect that we're going to use is going to be float base aspect equals to 9f divided by 16f. This is the original one. But we should check if we are using a different aspect ratio. So we need to get an aspect, what I just said, the aspect variation. So we're going to type float aspect variation equals to game camera.aspect divided by the original, by the base aspect. Okay, so if we are in a 9 by 16, this is simply going to return 1. But if we are in a 3 by 4 aspect ratio, this is going to return something a little bit bigger than 1, a little bit bigger than 100%. And with that information in mind, we should be able to tell what's going to be the horizontal range. So let's define a horizontal range here. Okay, we just have depth, but we're going to type also public float horizontal range. We're going to leave it public so we can easily check its value. Okay, so let's come here and we're going to type horizontal range equals to aspect variation multiplied by, and how do we get the size of the camera? We simply type game camera.orthographic size. Okay, so let's save this and try it out. Okay, so set the horizontal range. Let's add this comment here so it's going to be easier for us to understand what's happening. So let's go to Unity. We're going to focus on the game controller game object. And once this is going to be finished, horizontal range is set to be 0 here. But if we press play, it's set to 8 because we are in 9 by 16. If we move to 3 by 4 and we press play, then it's going to be a bit bigger. It's 10.66 and then it simply goes on. But the thing is, the orthographic size for the camera, Okay, if you go to the scene window and you see the camera, it's going to return the entire size for it. Okay, so from the left to the right, but we only want half of it to make our calculations easier. So we simply come here to where we set the horizontal range. We can put these between parentheses to make it easier to read. It's not mathematically necessary, but that's a good thing to do this. And we divide that by 2f. Okay, so it's going to be half of whatever we have. So we save this, we go to the game, and we can test this one more time. I'm going to set the aspect ratio to 9:16, and in the game controller I'm going to press play. You're going to see that the horizontal range is simply 4, which is true, and the importance of this information is we can set the player to move between 4 and -4, and if we start this game at 3x4 and we press play, and look at the game controller, you're going to see that the horizontal range is 5.333. If you go to the player, you can set its position to be 5.33, so it's going to be in the right limit, or you can set to minus that value, and it's going to be in the left limit. Okay, so this is great. This is something that we're going to use with all of our game elements. So now that we have this, we should go to the start method where we set the player depth range. We're going to set player.horizontal range equals to horizontal range. We of course need to make these variables inside the player, so we have that range here, so private float horizontal range. We also need the property for this, public float horizontal range, then set and horizontal range equals to value. Okay, so we have this property here, and we need to keep the player within the horizontal bounds as well, not only the depth ones but the horizontal ones. So to make this easier, let's copy this to save some time and paste here, and let's be very careful to what we change here. So keep the player within horizontal range. So we check if the position on X is greater than horizontal range, and also we check if the position dot X is lesser than minus horizontal range. Okay, now here where we set transform dot position, we're going to say that instead of repeating X, it's going to be horizontal range, then we have Y, and then we have Z, transform dot position dot Z, and in the second case we're going to put minus horizontal range on X, Y is repeated and Z is repeated as well. So transform dot position dot Z. Okay, so let's review this. We check if we are in the left, in the rightmost portion of the screen. If we are, we set the X to be fixed in a horizontal range, Y and Z repeat. If we are in the left side of the screen, we set its position to be in the left side of the screen so it doesn't go further beyond. We repeat Y and we repeat Z. Okay, so this is what we have. Let's try that out with by practice. Okay, so we save that, wait for the compilation to be finished, and we press play. Okay, so if I move the player to the left, it's going to be sticking in this place. To the right, sticks on this one. But if I go to 9:16, it should be a bit different. Okay, so we press play, it sticks here, and then it stays here. Okay, so we make the player stay in the limits. By the way, let's choose the player and change it to 0. So it's going to be starting in the center. And now what we have to do is do the same thing for the enemies that we have. Let's set that by 3x4. And let's go to the rolling enemy, and we're going to put here a private float horizontal range. Okay, then here we're going to type, apparently we have something wrong here. Okay, so yes, we already have horizontal range here, but let's remove this one. Let's just leave it here as private, because the one that is going to set that is going to be the game controller. And then public float horizontal range, then set horizontal range equals to value. Okay, so that's our property. We close the curly braces here, and now we move to the game controller where we load the rolling enemy, which should be here. Then we can copy this line and paste here, and instead of calling depth range, we type horizontal range equals to horizontal range. Okay, now we can save this, go to Unity, and in a 3x4 we can check that the enemy is also going to be in the left and right limits. So we press play, the enemy is in this side, it's going to move to the other one, okay, then it's going to move back, move down, and well, keep rolling like that. Okay, so we have a little challenge here. So to improve this enemy a little bit more, since the room is bigger here, let's change its speed to 7 and waiting duration to 0.5. Okay, this might be a challenge. So as we make this game, we're going to tune the values, okay? I think it's going to be more interesting this way, so we avoid as much as we can. Okay, and now that we did this, we should also adjust the jumping enemy. So we go to the game controller, we go to jumpers mode, so we can quickly switch what game we are playing, and we're going to open the jumping enemy script. Okay, notice that we set the target horizontal position for the horizontal range here. So we do pretty much almost the same thing. So instead of making horizontal range public, we're going to make it private. So here, I'm going to type private float horizontal range, then the property. Public float horizontal range with uppercase H, then set, then horizontal range with lowercase h equals to value. Okay, then we close this property, and in the game controller, here where we have the jumping enemy, we get jumping enemy object dot get component of type jumping enemy, and then dot horizontal range equals to horizontal range. Okay, so we can save this, go to Unity, let's wait for the compilation to be finished, and we can press the play button and see that the jumping enemy is going to move from between these limits that we defined. Okay, so before there would be a very small range where it would move, but now there is a larger range for us. Okay, so you can move to this side or to the leftmost side, and it's going to keep working like that.